Alright, we're going to look at using our trigonometric functions today for the first time and our ratios. So previously I've shown you that they exist and made you write them down at least so you have a copy if you haven't memorised them yet. And I've shown you some algebra to remind you how some of this stuff works. So we're actually going to use trigonometry to find something out for the first time today. A very important first step is noticing what tools you're going to need to use for any question. So this is a right angled triangle, and you've learned about Pythagoras' theorem and you've learned about trigonometry a little bit so far. If this video wasn't called trigonometry, how would you know it's trigonometry? Well, Pythagoras' theorem requires 3 lengths, and this only has 2. Trigonometry is about angles and lengths, and oh look, we've got angles and we've got lengths. So this must be trigonometry. Once you've pinned it down to trigonometry, there are 3 functions: sine, cosine and tangent. How do you tell which one to use? Well, I would always recommend labelling the sides that are in the question, the sides you actually care about. So here we've been given this 18 centimetres that I'm going to use, and that's the long edge, so that must be the hypotenuse. And here we've got this 14 centimetres, which is next to the angle, so that must be the adjacent. So which function links A and H? Now if you've got your notes from the last couple of videos with you, you can just look up that A divided by H is cosine. Otherwise you could use SOHCAHTOA, but you need to have some way of looking up and knowing that A is linked to H using cosine. So the formula that we're going to use is that the cosine of an angle is equal to the adjacent divided by the hypotenuse. Alright, in this case the angle is just x, so that's just substitution. The cosine of x is the adjacent, which in this case is 14, divided by the hypotenuse. And just like the previous algebra, I'm not going to bother simplifying that fraction down because quite frankly I don't care what it is. I care about what the angle is, and that's the only time I'm going to use my brain. I don't want to waste brain power on things that I don't need to know. This is complicated enough. So, I need to get this x by itself, so I know what it's worth. What is currently being done to x, so that we can... currently being done to x, that makes it not by itself? Well, we're doing the cosine function to it. So I would like to get rid of the cosine function. I'd like to uncosine in some way. Now, unlike squaring and cubing and other things you've seen, there isn't a nice name or another name for uncosining. It's just called the inverse cosine, which just means uncosine. Sometimes it's called the arc cosine if you've got an older teacher or an older textbook, but you just uncosine because we want to get rid of it. So we're going to do something to this fraction which is uncosining. It hasn't got a very interesting name either, so we're just going to write that down using these symbols. So that -1 is the notation we use for inversing a function in some circumstances. So this is the uncosine, the arc cosine or the inverse cosine function. It undoes a cosine. So if you've got a cosine that you don't want, you can get rid of it by uncosining. Now x is by itself, and over here we haven't got any letters left, we've just got numbers and functions, so this is a number. So let's get a calculator out and see what that number is. Shift. I should probably point something out for the first time. At the top of your calculator you'll have this little black box. Mine should have a D that you can see in black. That's because we're measuring the angles in degrees. We can measure angles in other things than degrees, and normally we like to use radians in higher mathematics, and the French try to use gradients for a bit to decimalize it. But we're going to stick with degrees because that's the angle version you know. That would be like swapping between centimetres and inches for no real reason. So degrees, we're going to stick in because we've got the D. So we press Shift and our cosine button, then that gets us this on the screen. Type the fraction in, and we get this horrible decimal, which I'm going to round, so that's roughly 38.9 degrees. So if I were to draw a right angled triangle with these 2 lengths, that angle would be 38.9 degrees. We'll try and do the next one a bit quicker. So label the edges. That's adjacent, that's opposite. So TOA, SOHCAHTOA, O and A is tan. So the tan of y is the opposite over the adjacent, and I want to get y by itself, so I'm going to untan this stuff using the inverse tan function and notation. I probably should stop saying function because I'm not entirely certain what the inverse tan is of true function. It's a mapping, isn't it? So any pedants listening will be satisfied by that. Type it in. So we're going to inverse tan this fraction, press equals, get a number, and that's 64.4 degrees. And finally, this angle here means that is the opposite, and this is the hypotenuse. O and H is sine, so, katoa. So the sine of Z is the opposite over the hypotenuse. To get rid of this sine, we are going to inverse sine. So that will be whatever our calculator says that is. And that comes out to be 56.44 degrees, roughly. So, that's how we can calculate an angle using trigonometry. You can stop there. I'm going to show you some calculator things in the next couple of minutes, so if you're just here to do the trig, crack on. Otherwise, just a couple of things about the calculator. If you're not sure you're in the right mode, sine of 30 should be exactly a half. And if you don't get a half or 0.5, your calculator's in the wrong mode. Now, depending exactly how your calculator's set up, where that is different. On these Casios, it's in the shift setup section, and you see option 2 is the angle unit, and you've got degree, radian, gradient. If I put it in the wrong one now and do sine 30, I get this other nasty decimal, negative 0.98-ish. So you can change it back into degrees. If you haven't changed it, it should be on degrees by default. If you've borrowed your calculator from someone who's done an A-level in mathematics or some other applied uses, they may well have left it on the more useful mode for their work. So do double check, and the simplest check is that sine of 30 is exactly a half. Sine of 90 being 1 is also useful. But sine 30 is a half is the most useful check. So, enjoy that, and I'll see you soon.